So we're going to be taking notes on quadratics. And so a quadratic we know is a second degree function. And with a quadratic, the graph looks like this big curve, okay? And this curve is called a parabola. Parabola, okay? We have lines for linear, quadratics have parabolas. And so we'll take a look at all the different pieces here. Some of them will be familiar to us. Some of them will have multiple names. And that's really important that we realize that, okay? So this first piece, this one right here, that is our y-intercept. We've seen y-intercepts before. From this point on, though, y-intercepts will not have the same amount of value, will not be placed at the same amount of importance that it has in the past. It was a really great starting point for linear functions, but moving forward, we have other things that will be a bit more helpful to us, okay? So in our parabola, we also have this point at the very bottom. This is the kind of our root. We're going to be starting the kind of the base of where we're starting our graphing. And this is called the vertex. The vertex, okay? When we graph a parabola, I would say 95 times out of 100, if not more, we're going to be starting with our vertex and going out from there, okay? Now, this dashed line, it's really invisible. It's not actually there, but it is a spot that's really helpful to understand how we graph. This is called the line of symmetry. Also known as the axis of symmetry. Okay. And it always runs through the x value of the vertex. Okay. It's the x value of the vertex. Okay. So not only is our last piece here, and this is really kind of the crux of the issue. This is what we're looking for when we have a quadratic, okay? Our graph is crossing the x-axis, so these are our x-intercepts. But there are three other names for them that can be used interchangeably, and we need to know all three of them, okay? X-intercepts, where they cross the x-axis. They're also known as solutions. Okay. That's often going to be the answer we're finding. They're also known as zeros. Okay, zeros, because the y value is 0 there. The last name is roots. Okay, roots. The reason we call them roots will become a bit more evident later, but think of it as oftentimes we'll have to find the square root in order to figure out what x equals. So the root is that, okay? All right, so these are the parts of a parabola, parts of a quadratic function. Let's try to identify them ourselves, okay? So our vertex, all I want you to do is identify the order pair of the vertex. Let's see, 4, 3 is our vertex. All right, our x-intercepts, where do they cross the x-axis? Let's see, right here and right here, okay? We don't know these exact values, and that's okay. What we do know is that our first x-intercept is between 2 and 3, and our second x-intercept is between 5 and 6. So we're going to write it like this. We have two different ones. We have 2 is less than x, which is less than 3. We also have 5 is less than x, which is less than 6. All we're saying is the x value of that point is between 2 and 3. The x value of this point is between 5 and 6. Could we narrow that a little closer? Sure, but we don't need to, okay? Now, lastly, we didn't cover it up above, but is there a minimum or maximum? Is there an absolute highest point or an absolute lowest point? In this case, our parabola has an absolute highest point, so it has a maximum. Okay. try this one on your own, and we'll do the third one together. All right, you should have gotten 4, -4. 2 is less than x, which is less than 3. 5, which is less than x, which is less than 6. So our intercepts end up being the same. Not quite the same, but they're not actually the same value, but our answer that we're putting down is going to be the same. Eventually, we'll get to exact answers. We're just not there yet. And this one, it does have an absolute lowest point here, so it is a minimum. Okay, this last one. Let's see, our vertex is 4, -1. Our solutions, okay. So our solutions. Does our parabola cross the x-axis? No, okay. Because there's no x-intercept, there is no solution. No solution. It's possible to have no solution, okay? That's because it doesn't cross the x-axis. And this one does have an absolute highest point, so it is a maximum.